Okay, gang, I'm gonna break this video into bits just so I can explain all the parts of it. So number 29, we want inflection and concavity. Okay, so the first thing I did is find the derivative. I would on this test give you the derivatives unless I want you to find a specific derivative, but in general this test is about applying them, not finding them. All right, so, but I just want to go over this, you know, for the final, it never hurts to review. So the derivative of 2 sine x is 2 cosine x. This one is the chain rule because it's got an outie and an innie. So the derivative of the outside, sine, is cosine. The derivative of the inside is 2. So that's how you get the derivative, because the second half is chain rule. All right, now I just rewrote it. I just brought the 2 like from here to here. Now, inflection and concavity is a second degree derivative. We need the second derivative. I don't know why my mouth can't talk. Okay, so now I'm going to do the next derivative. So derivative of this is this. And again, you got to do chain rule here because it's a composite. It's got an outer layer and an inner layer. So the derivative of the outer layer is this. Derivative of the inner layer is this. And again, I just made it look nice. I just brought the 2 over here. Musical chairs, right? We just move this over here. And now I have this. Now the thing is that the period of this guy is pi, 2 pi. The period of this guy is 2 pi. The period of this guy is pi. So this guy is oscillating twice as fast as this guy. So for me to solve this, I need to get these guys oscillating at the same rate. So for me to do that, I'm going to use the double angle formula. So instead of having an x and a 2x, I can just have an x and an x, an x. All right, so the double angle formula is this. I then rewrote it in terms of x. I wasn't sure if the u was going to be there's too much going on. So here's the formula. So I replaced this with the formula, double angle formula, and then multiply this times this, and we get that. Now, to solve something like this, which we need to do, we need to find the critical points, right? The critical points are where the derivative is equal to 0 or the derivative is undefined. The derivative here will not be undefined, but the derivative can equal to 0. So that means that I need to take this and set it equal to 0. Okay, so I'm going to take this guy. Because I'm looking for the critical points. So I want to set this equal to 0. So you need to solve something that looks like this. So to solve something that looks like this, you're going to use the zero product rule. Okay, the zero product rule means you're going to factor out the common factor. So I factored out a negative, a 2, and a sine x. I factored out a negative, a 2, and a sine x, and that was what was left. Okay, so this is a zero product rule, right? Something times something equals, if something times something equals to 0, then either the first thing is 0 or the second thing is 0, right? That's the logic. All right, now I also didn't originally have the cut on the question. So we have to stay in between 0 and 2 pi. All right, so for the first one, you set it equal to 0. You're also going to set the second part equal to 0, but let's work on the first one right now. So you set this equal to 0, you divide off the negative 2. You want to know where sine equals to 0 on 1 revolution. All right, so sine will equal to 0. You have to use the unit circle because that's a quadrantal angle. The sine will equal to 0 at 0 or pi because the output, which is the second value on the unit circle, will be 0, and that's what we're looking for. So 0 and pi. Now, it's not that 0 is wrong, but if you remember the cut I just said, you're on the end point of the cut. So since we're an end point, this one isn't significant, but this one is. Like, we're going to need to put pi. We're going to need to put pi up there, but this one is already an end point, so this one we don't need. All right, so that's that part. Now we go back to this part. This part is heavy pre-calc, heavy pre-calc. You set this equal to 0. You isolate the cosine function. Now, you need to figure out what x is. Cosine is not multiplied times x. This x is in it. This x is in it. Like your brain is in your skull. It's in it. So you couldn't, like, To get x by itself, you can't divide the cosine off because it's not multiplied. Just like you couldn't divide your skull off your brain. You can't, because one is inside the other. What you have to do is you have to apply an inverse. An inverse. Okay, and something that will undo. You have to undo the cosine. So just to give you like a quickie little example, if you have an x squared, what undoes an x squared would be a square root. You want to think of like undoing. So from pre-calc, what undoes or would undo the cosine would be the arc cosine. I know you're probably like getting the Tylenol right now, but it's the arc cosine. So you have to apply the arc cosine to both sides. The arc cosine of cosine, since they're opposites, undoes each other. They undo each other. And then over here on this side, you have to put this in your calculator. Now, if you don't remember, this is shorthand. This guy on the top, this is shorthand for arc cosine. So you have to actually hit second. You have to hit, let me just do it so you can see it. You have to hit second arc cosine of negative 1/4. Okay, I didn't think about the units for a moment. I'm in degrees right now, so it's going to give me 104 degrees. So the angle is 104 degrees, which I should have put somewhere here. I did. Okay, so, and let me even back up a little bit more than that. You have the angle now. Your brain knows that if you put this in the calculus, it's 104 degrees. But you have to remember that the arc cosine in pre-calc, the arc cosine only lives in quadrant 1 and 2. You were taught that because it has a restriction, because it has to be 1 to 1 so that it has an inverse. So you were taught that the arc cosine lives in quadrant 1 and 2. In quadrant 1, the arc cosine is positive. In quadrant 2, the arc cosine is negative. So when I was solving this, I knew that this angle was bringing me into quadrant 2 because the arc cosine was negative. And then as we just saw, we said that the angle was 104.5 degrees, right? We're crunching that out. So, and again, I want you guys to also get used to radians is really the better one to be in, just to be very frank. I know that it's easier to understand degrees because we see that more often, but let me also just, you have to sort of force yourself if you're not comfortable with radians. You have to sort of make it till you're comfortable. Okay, let me just change the radians just so you can see that. So then arc cosine of negative 1/4. Right, that's 1.8 radians. So these are both the same value. They're just in different units, right? This one's in radians and this one's in degrees. So that is what's giving me that first answer. Okay, so that's how you solve the arc. Okay, I've now solved the arc, but I have to now back up. Okay, up to here, just make sure you understand that I solved the arc. Now the reason I have to back up is because we're solving actually this problem here. And the cosine is negative in 2 quadrants, not 1, in 2. It's negative in quadrant 2, just like we discussed. And it's negative in quadrant 3. So the reason I had to do this step first is because if I know what this angle is, I can calculate the reference angle here. And then once I know the reference angle, I can put it here and then calculate this standard angle. Okay, so the reference angle, and let me see if I wrote that part at all. I'm not sure if I wrote that down. No, I didn't. Okay, so maybe I'll come back with the next video, and I'm going to explain now, because there's 2 answers here. There's one for this problem here that we're about to solve. There's 2 answers. There's one coming from quadrant 2 and there's one coming from quadrant 3. We have to find first the quadrant 2 angle using the arc cosine, and then we'll find from there the quadrant 3. All right, let me end this one here and then I'll pick it up. In a moment. Okay, catch you. Bye.